Hello, today we're going to talk about sound. Sound is created by vibrations of longitudinal waves. So a longitudinal wave is a wave that sort of like the slinky. It has areas that gets compressed, then it spreads out. Then it gets compressed. The areas that it gets compressed are called compressions. These are areas of high pressure. So it goes high pressure, low pressure, high pressure, low pressure, and it just keeps changing like that until it eventually runs out of energy. All right? These areas right in the middle of it are called rarefactions. Rarefactions are the points of low pressure that are right in the middle. The magnitude of both of these at the compressions and the rarefactions are equal. Even though this looks, you might think a compression has more energy or more amplitude, it does not. Rarefactions and compressions have the same magnitude. Their magnitude equals each other. How fast these travel is the speed of sound. So you have solid, liquids, and gases. Because solids are so compressed, speed of sound is based on the stiffness of an object. Solids are all the particles are very close to each other. So if one gets just a little bit of energy, it pushes the other one. Whereas gas, they're spread out and it takes more energy for them to hit. In a solid, speed actually travels faster than in a gas. Liquid's the in between. So if you're ever asked, what is the speed of sound travel, or what does sound travel fast through? The ground. If you watch those old cowboy movies, they put their head against the ground and they say, oh, I can hear them coming for us. Or you put your head on a train track, you can hear the train coming way before you can hear it just standing up and trying to listen to the air. Because sound travels faster through a solid. Now there is a way to figure out how fast it travels through a solid, or how fast it travels through an air, and that is with your velocity formula. So velocity, is distance over time. Now we're going to change this. You can also change it to time equals distance over velocity, or whatever you want. So the first one we'll do is we want to know if you're 600 meters away and the sound is traveling 250 meters per second, how long does it take to get to you? All right, so I see something 600 meters away, an explosion, and then it's traveling 250 meters per second to get to me. How long does it take? So I'm looking for the time. My distance is 600 meters away. My velocity is 250 meters. And when I divide those, I get 2.4 seconds. So through the air, it takes 2.4 seconds for an explosion 600 meters away that's traveling 250 meters per second to get to me. That's the way you can figure out sound, the time it gets there, or the distance. All right, we're going to actually find out the actual speed on this next one. So if I tell you you're 340 meters away from your kid yelling as loud as they can. All right, it takes 6 seconds to get to you. What is the speed of sound? So right here, you're 340 meters away. It takes 6 seconds. You divide those and you get 56.7 meters per second. So there you go. That's your speed of sound through the air. And there you go. Speed of sound all depends on what medium is traveling through, the stiffness of it. The solid, it travels faster through a solid than a liquid and a gas. Liquids travel faster than a gas. Gas moves through the slowest. All right, and the last thing is temperature can affect the speed of sound. This is the formula for it. I'm going to go over it. So I'm going to say I'm somewhere where it's 5 degrees Celsius. All right. what's my speed of sound? Alright, so all I do is plug this in for my T right there, or what's my velocity? So 331, I'm gonna get rid of the meters per second because I don't like it, times 5, that gives me 3, so 331 plus 3 was 334 meters per second. There you go. All you do is plug it in. And I'll do, what if I had 20 degrees? Let me switch my colors. Alright, so then I just plug it in, 331 plus 0.6 times 20. So 331 plus 0, 12. It's been a long day. 12. So 3, 4, 3 meters per second. And there you go. That's basically just the temperature effect on it. It was just in a lesson, so I thought I'd teach it to you. All right, it's been sound, what it is, and a couple other things. Hope it helps, and good luck.